Okay, we were talking about nomenclature. Nomenclature of hydrocarbons that were aliphatic compounds. See how smart that made me sound? Okay, so we're getting ready to build up our vocabulary even more, and this is going to start with our nomenclature section. So I told you that we were going to start off very simple, all right? And this is our first alkane. And we need to learn how to name this alkane. All right, so here's the system that we have to put in place. Whenever we see one carbon like this, we use the prefix meth. Okay, it's not meth like you think it's meth, all right? That is related, but that is, of course, completely different. So we have to put an ending on it. Meth represents one carbon, not methamphetamine. And the ending that goes on to meth has to have a proper ending that denotes to me that this is an alkane. Okay, so a group of PhDs got together and they sit around a table and they talked about what we called IUPAC rules. And IUPAC rules stand for the International Union of Pure and Applied Chemistry. So all of these special PhDs with nothing else to do that think that they can run everybody else sit around a table and said, well, how can we name these and bring a system together? And someone with that much education said, well, we need to put an ending on it, and that ending we need to kind of figure out what would be suitable, and we need to brainstorm, and we need to combine all of our ideas together to see which one is the best one. And they sit around and someone said, well, hey, why don't we just use the ending of alkane and put it here on the end? There you go, methane. That's how we name these compounds. Whenever you see the ane ending, that ane represents alkane. So that is a trigger. And that trigger basically should make your brain think single bonds. Single bonds, single bonds, alkanes, alkanes. All carbons, hydrogens at this point. That's all that it is. So one carbon is meth, therefore methane is going to be the name of that structure. Now I can do condensed structure. Methane is a carbon and there's 4 hydrogens. So there you go. So you have the Lewis dot structure, you now have the condensed structure, and you now have the proper name that's associated with that compound, and that you have to remember, all right? You know good and well on the very first test, or maybe the second test at this point that I'm going to give that represents this material, I'm going to say, name it. So this is a word that you're going to have to learn, not memorize, but learn, and we'll use it so much that I think you will learn it by the time this is over. Okay, so now we're going to build up, and we're going to do 2 carbons. 1, 2, and we're going to have enough bonds on these to make sure that everything is fully saturated. So there you go. And then we're going to load up enough hydrogens on them to make sure that they all have what they need. Each carbon has 4 bonds that go to 4 things. It's all single bonds. It's aliphatic. It's a hydrocarbon. There you go. Well, what we used for a 2-carbon system here is the prefix eth, ETH. So drop the M off of meth. Just erase it. And this is eth. And this is still an alkane. So it's still an ANE ending. Hopefully you'll start to see a pattern that begins to evolve. So this is called ethane. And if I wanted to draw the condensed structure, I can. This is C2. And this is H. 1, 2, 3, 4, 5, 6. H6. All right, so that's one way that I could do the condensed structure. But sometimes this really doesn't give us an idea of how these things are grouped together. Okay, it's kind of vague. And some people will draw a condensed structure a different way. And what they do is that they will focus on this first carbon and they'll draw that down. And this first carbon has 3 hydrogens on it, right? So they'll do CH3. And then they move on to the next carbon. So here I'll draw another carbon, and then this has 3 hydrogens that are attached to it. So some people will draw ethane as CH3CH3. Folks, either which one you want to do, it doesn't matter. They both represent the same thing. Who cares? I mean, what works for you might not work for me, but we're telling the same story, aren't we? Our narratives are a little bit different, but overall it's the same story, so who cares? I shouldn't care, and neither should you. All right, so now we move on to another one. All right, so with this one, 1, 2, 3. And I'm going to add a total of 4 bonds onto each one of those carbons. So there we go. All have 4. And then I load up enough hydrogens on each one of those to satisfy everything. There's our Lewis dot structure. Carbons have 4 bonds, hydrogens have 1 bond. They're whee happy. So the prefix that we use here, 3 carbons in total, all the way across, is prop. P-R-O-P. Yes, that is an R. I know that looks like a squiggle, but that is an R. Prop. And what ending do you think we use? You got it. Ane. Propane. All right, so you know what propane is. I mean, if you have a gas grill at home, you know what propane is. No big deal. Well, now you know the structure. Just by recognizing what the name means. That's the power of organic. Do you see what just happened? Yeah, you've heard of propane before. You've maybe have purchased a propane tank. So this propane gas inside of the propane tank. Well, just by looking at the name of something, you automatically have a vision of how this structure is organized. So nobody said that chemists were smart. We just know the rules that we have to follow. And there you go. So I can draw the condensed structure. So this is 3 carbons in total, C3. And then I can put an H. And I count up all the hydrogens. 1, 2, 3, 4, 5, 6, 7, 8. It looks like I've added 8 to it all the way around, right? So C3H8. Or, if you like this better, feel free to do it. I take the first carbon, and there's 3 hydrogens on that carbon. Then I move on to the second carbon, and there's 2 hydrogens on it. And then I move to the third carbon, and there's 3 hydrogens on it. Folks, there you go. There's the structure of propane. That is why we call it propane. And there is the condensed structure of propane. All right, so before I clear out this screen, you have to remember, meth means 1 carbon. Eth means 2 carbons. And prop means 3 carbons. And this will hold true throughout the majority of the organic lectures that we are going to have together. All right? Okay, well, we can't stop at 3. We're going to keep going. So this time we're going to connect 4. There we go. 1, 2, 3, 4. And I'm going to put enough lines to have each carbon have 4 lines in total. And that means now I'm going to have to go around and add enough hydrogens to make them all happy. I mean, it's like having a bunch of kids here, and you got to be fair to every one of them and make sure you don't get out of line. They're real needy and clingy too. Okay, so here's the structure. There's 4 carbons in total, and the prefix that we use for 4 is but, B-U-T. What ending do you think we give? That's right, it's an alkane, so we add A-N-E at the end. So if you're a smoker and you have butane lighters, folks, you now know what's inside of that butane lighter. Here's butane. Okay, so butane, I can draw the condensed versions. I have 4 carbons in total, and hydrogen, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. H10. Folks, keep in mind, CnH2n plus 2. I didn't really talk about it on the last 3, but they all work. You have 4 carbons in total. Hydrogen, 2 times 4 is 8, plus 2 more is a total of 10. It meets the definition. It should. It's an alkane. But if you didn't want to draw it this way, you could draw it another way. I don't care. carbon with 3 hydrogens on it, and then a carbon with 2, and then another carbon with 2, and then a carbon with 3. There you go. There's butane. Some people will write this another way. It really just depends on who you are. And what they decide to do here is CH3. And do you see how this repetitive block happens? CH2, CH2. Well, they'll write CH2 like this, and they'll just put a 2 out here to let you know that there is one of them and there is 2 of them. And then they'll cap it off with the remaining CH3. That's okay too. No big deal. You shouldn't mind. I shouldn't mind. And we really don't. Okay? Summary chart. If you take a look at the summary chart so far that we're building up, here we've made it ourselves up to butane. This is what you're going to see in your text, and this is why you see it that way. So here you're seeing the name methane, ethane, propane, butane. And here you see what we call the molecular formula. And the molecular formula is what we have been doing. So 1 carbon, 2 carbon, 3 carbon, 4 carbon. And we're just combining everything together in one kind of condensed version. This is the Lewis dot structure. I know I called it Lewis dot structure. There's really no dots that we've been writing because there's no free pairs of electrons, which is a very good symbol that those free pairs of electrons are not present, so therefore these compounds are nonpolar. And they are nonpolar structures. But here, they're calling it a calculate structure. The reason they're calling it a calculate structure is because if there were free dots here, they probably wouldn't be drawing those either. So if we did have oxygens and nitrogens and so forth that would carry a free pair of electrons, they typically leave those off like we have talked about before. But here in the world of hydrocarbons, we don't have to worry about the majority of that most of the time. All right, there's some exceptions, of course. There are some changes that we'll talk about, and we're going to see those. But at this point right now, these are calculate structures with no dots at all. Finally, the condensed structure over here, this is what we've been doing when we begin to write out each particular carbon. So this is called the molecular formula. This is called the condensed structure. Both of these are okay. It doesn't really matter which one you write down. Quite honestly, I don't care. You just find something that works for you and what you feel comfortable with. And then what happens over here to the right-hand side is the ball and stick model. We have to keep in mind that these structures are 3D. So in a 3D world, we have to think about shapes, and we have to think about bond angles, and we have to think about bond lengths. So ball and stick model gives you an idea of this. And if you look, the first carbon's pretty simple. It's just 1 carbon with 4 hydrogens. Again, very much like a tripod with a camera that sticks up above it. When we get to ethane, we see a tripod on to the left and a tripod in to the right, and they are connected together in the center. But when we start getting to propane and butane, what we see is a little jagged piece that begins to happen here. At each one of these, it kind of kinks itself over. And what we end up doing is seeing these structures that begin to bend and kink on us the bigger and bigger that they get. So it's very often that we will begin to draw these little zigzag lines because of that. And these zigzag lines are going to represent this motion that is set in place. So the bigger that these molecules are going to get, the more that you are going to see us draw these little zigzags as a shortcut. All right. So what you're going to see on the screen now is a shortened, abbreviated 5 through 10. Okay. So if I have 5 carbons in total, 1, 2, 3, 4, 5, that is going to be called pent. Think of pentagram, right? If I have 6 carbons in total, that's going to be called hex. All right, so hex, H-E-X, see the X in it? That represents 6 because it has X in it as well. Hept, H-E-P-T, represents 7. Oct, think of octopus, 8. Non is going to be 9. And dec is going to be 10. Those you have to know. So prefixes 1 through 10. You've got to learn these people. You have to learn them in order to do well in organic. So meth, eth, prop, bute, pent, hex, hept, oct, non, dec. All of those are prefixes that represent carbons 1 through 10, which are the most common structures that we're going to be focused on in the class. You have to be able to name all of those. Now, I want you to keep in mind that there are things after 10. Okay, we go up to 20s and 30s and 40s and 50s. I mean, this is something that we do, but I don't want you to name those prefixes. Phew, thank goodness, right? I mean, that would be tons. 1 through 10's good enough for me, and it's good enough for you at this moment in time. All right? So 1 through 10, those are your prefixes, but once more, look at all of your endings. Ain, 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 ain. And you saw ains on all the other ones as well. That is very symbolic that you have an alkane, and that alkane means all single bonds all the way down. Just a quick review. This decane, that's a lot to write down, isn't it? CH3, CH2, 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 CH3. Didn't even want to say it. It was too long, right? So you could, if this is what you wanted to do CH3 parentheses, CH2 parentheses, and there's 1 and 2 and 3 and 4 and 5 and 6 and 7 and 8. So CH2 8 with a CH3 at the end. That is much quicker. It's much shorter. There's less work that's involved if that's what you want it to do. And now you see why people do it. The bigger the molecules get, the more convenient that that's going to be. Okay? All right, so what you see on the bottom of the screen, typical test and quiz questions that you're going to see from this. Draw the structure of butane. So I just basically want you to draw them out and give it to me. Name the molecule below, and I could give you the structure, and then you would have to give me the name. So I like to play both ends. I don't like for you to get comfortable only going in one direction. This is a two-way street, okay? You're going to have to learn how to drive on both sides of the road. So what that means is that you're going to get questions from me that say, draw these, and then you're going to get questions from me that say, well, here's a structure, now you name these. So be able to go back and forth pretty comfortable when it concerns the test and when it concerns the homework that I begin to give out for you that you'll do on a sheet of paper. All right. Here's a more exaggerated table. Notice 1 through 10 is listed, and it kind of stops there. That's I don't want you to know anything else after that. But look at 11. 11 is undec. Un means 1, so 1 and 10 is 11. 12 is dodec, so do is going to represent 2, and dec is going to be 10. So 2 and 10, that's going to be 12. Every time I think of this, I think of dodo. And then when I think of dodo, I think of honey boo boo. So, you know, dodecane just does something to me. It makes me feel uncomfortable. Number 13, tridec. So tri, of course, means 3, and dec means 10. So 3 and 10 is 13. If I go to 20, 20 really uses a completely different prefix. It goes to ico. So this is icosane. 21 is hene icosane. 30 is going to be trioctane. So all of these are going to be prefixes that you do not have to worry about, but once more, they do get bigger and bigger and bigger, and we do have terms that come along with those. All right. Something else on the table that I think it's important for you to look at are the boiling points and the melting points. The boiling points, melting points, and even the densities. There's a trend here. Notice what happens, and we're going to talk about this trend later on in a different video, but look at your boiling points. You start off small and you get bigger, right, in structure. And boiling point starts off negative, really, really low, and it gets bigger, 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 bigger as we go down. There is a periodic trend with boiling points and with the alkanes. The bigger the molecule, the larger the boiling point's going to be. Melting point's going to follow the same trend. So it starts off low and it gets bigger, 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 bigger as you go down this chart. Density, very similar as well. It starts off low and then it gets bigger, 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 bigger as you go down the chart. So what this means is that later on, we'll be able to compare structures, and just by looking at the structures or the shapes of these structures or the number of carbons in these structures, we will be able to pinpoint which one has the highest boiling point, which one has the lowest melting point, which one has the highest density. We'll be able to compare and contrast this way. Very easy to do. You just need to know the trend in order to do it. And this does not require a Google or a search engine for you. All right. Now, another topic that I need to talk about before we go further into this discussion. And this topic is going to involve the term isomer. So that's where this video is going to stop. Okay, we've introduced organic compounds 1 through 10. We now know the prefixes that we like to use for them: meth, eth, prop, bute, pent, hex, hept, octa, non, dec. There we go, 1 through 10. But before we go further, we're going to also have to talk about this term called isomer. So that's what we're going to do in the next video. So stay tuned, come back. Again, if you need to take a potty break, go take a potty break and then come back. We're on a roll. I know that you want to learn about isomers. I know you do. So I'll be here waiting when you are ready to push the play button.